So our workbench is open. We will bring geometry module here, and with the right click, it's going to be a new design modeler geometry. Geometry screen pops up. We will import external geometry file. And we'll bring it. So here is the imported geometry. We have some blade design with number of blades and associated hub. With that, we don't have to shroud at the moment, but we will generate that one. So we're going to stay on the ZX plane to proceed further because we will create some sketches. So we have to get here and then select the ZX plane, and then let's create a new sketch. If you go to the sketching section, we have a lot of alternatives to use. We'll use the rectangle, and let's make this aligned better. So I'm gonna select the rectangle and then provide some, cushion, if you will, on the front and the rear end, and use only the upper half of the body, and the rectangle is gonna end by the axis, as you see here, and that is it. We have our sketch available. Then we will convert this to a surface, and for that, in the concept surfaces from sketches, we will use that sketch, and there you go. We can make this at frozen too. That's gonna be a better looking one ultimately. There you go. So now we have the sketch and associated surface with that. Now at this stage I will create a cylinder to define the shroud geometry and the dimensions, and for that purpose, let's go to the primitives, cylinder, and it's going to be, again, it's always good to make this at frozen. The z coordinate origin, wait a minute, I'm going to have to change the units so that it's going to help us better, but I guess I have to do that first. I have to do something. Let's put that first, and then generate, and then units. Let's use inches and get the cylinder again. Edit selections. Okay, so it's going to be 1.4 inch on here. The z component is going to be -6, and the radius will be 0.236. Okay, so this is how the cylinder is positioned at the moment. As you see, the cylinder diameter is pretty much flushing the total impeller height, and I deliberately chose that, but we're gonna perform a few other simplifications for better streamlined workflow. And now what we will do is we will split the surface that we generated using this the surface exterior surface of the cylinder, and for that we will go to the tools and face split. There you go. Now it will be by surface. The target face as you may imagine, it's going to be that one. The tool will be this one. Now, now we actually generated the split here. Now it's actually better visible. See that we have an upper portion of that surface and the lower portion is within the cylinder already. Now we'll perform another face split. And I will use hub, but before that, let me hide this body so that I can reach to the hub. Similarly, by surface. Now my target is actually the lower portion. The tool geometry will be, let me see if I can precisely select the hub geometry. So with that, we created this middle section, which describes the region between the hut and shroud, and the blade will be positioned there, of course. So I will create 4 new sketches to define the inlet, outlet, hub, and shroud locations. And let's go there and make a new sketch, and let's name this as inlet and go to sketching, and then it's going to be a line between it's going to be better if we zoom in to the location and then zoom out later on. There you go. This is inlet. So I created those after the inlet, outlet, as you see here, hub, as you see here, and shroud, as you see here. Now let's define the flow path. In the blade editor section, you will see a bunch of different options that we could use, and from here we're going to select the flow path. And we don't have to define the machine type at this moment, but for hub contour we will select the hub. For shroud contour we will select the shroud. Similarly, inlet and outlet. And for the other selections, we don't have to specify the number of layers. I guess it's going to be created by itself. Let's generate. There you go. Now we have defined the flow path. So at this stage, I'd like to demonstrate some further simplification steps that could be helpful. For example, now in our CAD file, we have the fillet region, and it's not going to help us to continue with that to generate the blade profile. So what we have to do is basically we have to cut the blade profile slightly above the flat region, and then we should create the blades with only the remaining portion of it. And then we're going to make some blade extensions. And I'll actually do this on the top section too, just to be in the safe side, so that the hub really crosses the blade tip. So let's create another sketch, and let's name it as trim sketch. And it's going to be again a line, and let's be aligned well so that we see things better. And I would like to stay above than that region. So as you see, the letter H is shown here. So it's going to make that this line is perfectly horizontal. So if you're actually dragging here and there, I mean, luckily that the software is going to make the line is actually perfectly horizontal. And now we're going to use this sketch to cut the regions. Of course, before doing that, we're going to create a surface out of that, and that will be using the revolve function. So we will use this location to create a revolve surface, which is going to be another cylinder. Again, you have another option of maybe putting a cylinder here and then using the cylinder surface to initiate that cut. But now I would like to demonstrate this. So let's get to revolve here. So the geometry is trim, and the axis will be the main axis of the geometry. Let's flip it, and it's frozen. So as you see, now we have a revolve. Of course, after doing this, what we have to do, we're going to um, create a slice using this created revolve surface. So let's create a slice, which is under the create section here, and slice by surface, and the target surface is the one that we created with revolve already, and the slice with all targets. I mean, a slice target is all bodies. So after the slice, what you see here, I kind of highlighted the other geometries. So we have the blades. So ultimately what we try to do is try to create the blade region with the defined sketches associated with those, and we have of course used just like the single blade. We need just like single blade, and we will generate others with a multiplier later on. So and now we have the blades, and we will continue with those. So let's continue with renaming the surfaces of the blade. I'm gonna be just focusing on a single blade at the moment. So let's name this portion as front. So similarly, I named the rear end, rear surface. Side, you can call this pressure side, the other one is the suction side, however you like to name it, depending on your application. And we can definitely also exclude the sketches from the view, but before moving on, I'd like to make an extend function so that I want to make sure the blade height actually passes the shroud and the hub surface. And in order to do that, we're going to use this solid extend, and get to tools here. This is a beta version. If that's not available, you have to go back to the workbench and turn the beta functions on. And when we do this, let's define like a very small offset. So I have the front portion extended. Similarly, I will do another extend with the same amount to the bottom portion. If it fails to extend, you have to play with the offset until you find a good one working. And now my blade is ready. I have extended blade regions for the hub and shroud so that we can create the flow domain in a better fashion. Now at this stage, we'll perform a CAD import. Again, on the blade editor, CAD import, create CAD import feature. And the flow path, we have already defined the flow path, remember? And is this the main blade? Yes. Number of blades, again, it's totally up to us. And let's make this 3, however we'd like to do it. And that's pretty much it. Of course, we have to define the blade surfaces, and that is either I can select with the name selections, or I can, visually, physically select. I'm only selecting, as you see, the sides and inlet and front and rear sections, not the top and the bottom. And now that is already completed. So we can actually write this going here. We're going to name let's name this test 2 and save. So before going to next stage, I wanted to demonstrate the blade profile that is generated after the CAD import function. And this is actually a good visual to indicate the profile of the geometry that we have. And the next stage will be bringing this CAD to a new design modeler, a screen, and continue to work from there.